Other math fans, a question from our discussion board as we get ready for exam 1 tomorrow. We're given the following relationship. When you see something like this and you get a collection of things, you should think about your vector facts, meaning the following. You should be thinking, okay, I know something about the dot product. This is going to be a general fact, either about this or about this. And while we're here, I'll say a couple other things. We should have this idea of if we add vectors, we can visualize it. The sum is this. It's this direction you're being pulled. We think about it as this head to tail rule or parallelogram rule. That's U plus W. Okay, the question is about a particular thing. I just thought I would say a few general things. So things that jump out at me here is they tell you the lengths of all these are 3, and this forms an equilateral triangle, and this is actually a homework question. And the key is that that's 60 degrees. So the first question is fairly quick. You say the magnitude of U, the magnitude of B. And the question wasn't about this, but I thought I would throw it in. And it's 60 degrees. You do have to make sure the vectors are tail to tail, but they are. If you were talking about W, just like you saw in the homework, you would need to move W so it's tail to tail. So for example, if I put W over here, then this angle, if you were talking about V, it's still 60 degrees, but if you're talking about U, it's 120. Okay, so that's the thing from the homework. And then you know the first one is 3 because they tell us. You know the second one is 3 because they tell us. And then you have your little trig values. Again, this would be a good thing for a note sheet if you don't know these. And you can really get away with knowing these first few. 0, pi over 6, pi over 4. So this is not what the question was either, but since we're here. So again, if you can just remember that sine of 0 is 0, you can fill in this whole thing. You can also think about the unit circle, but it just increases from here. So it's 0, 1/2, root 2 over 2, root 3 over 2, 1. You can actually do 0, 1, 2, 3, 4, and then do square root and divide by 2. And then it just flips here. 1/2, square root of 2 over 2, square root of 3 over 2, 1. There's all sorts of ways to remember this. I mean, cosine initially is bigger, so the first couple it's bigger. All sorts of ways you can think about it. All right, so let's get back to this. What are we doing? We are doing cosine of 60 degrees. So this is 1/2. So there we go, 9/2. Okay, so the question was about this one, and it's about a vector sum. There's a couple ways you can think about this. One is 2U is going to be twice as long as U. So if I were to draw it, it's going to come way out here. 2U and 2W is twice as long this way. And so you might even be able to visualize what this is. If you added these together, that it's actually going to be 2V. I think in my solutions, I pulled a 2 out, and that's what's confusing people here. This is really about a vector sum. You had to think about what to do with the 2. If you ever were confused by something like that, you could run an example, meaning just make up a couple vectors. What if this is 1, 2? What if this is, let me make sure you can see that. Sorry, quick adjustment here to my screen so that I can see. I find this helpful when you're working a general problem to run examples, just to make sure your reasoning is not off. Can you factor out a 2 there? Meaning, is it the same as this? 1, 2 plus 3, 4. You could just compute them both. So you could say 2, 4. This is just to get a sense. This doesn't prove anything, but it gets a sense of the idea. So this would be 2 times 4, 6. So here I added first. Here I multiplied first. Do I get the same thing? Yes, I do. So if the 2 is really, I mean, we actually could do this, but my intention was when I wrote this question that students would have to think about the fact that they can factor out a 2. Yeah, that's not like a named fact. So that was probably the biggest challenge there. But then this is the vector sum. And again, we could have actually just tried to visualize it and seen that it was twice. This right here is the way things are drawn. If you add these two vectors, they're already drawn the way we would want, the head to tail. So that is indeed V. And that was really the observation of the question. This is the length of V. And they told us the length of V is 3. So this is 6. And let me know if I make a typo. I'm not checking solutions. And so last thing, the area of the triangle, that's going to be 1/2. And you can use any two of the vectors of this. So that's this other fact. So it's the magnitude of U, magnitude of V, sine of theta. And so we have a couple things to do here. I forgot my 1/2. 1/2. Now we're talking about U and V, so I do get to use 60 degrees. And that's square root of 3 over 2. So it's going to be 9 over 2, because 3 times 3, square root of 3 over 2. Okay, let me know if I made some serious gaffe there, but those are the ideas. All right.